Assalamualaikum warahmatullahi wabarakatuh. Today we are about to present our project. We are from the group 7. Firstly, I will to introduce our team members. My name is Syed Muhammad Firdaus bin Syed Zakaria. My fellow teams Muhammad Syahrul Nizam bin Jamaluddin, Nur Farahin binti Muhammad Fauzi and Nurul Hidayah binti Ahmad.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Syahrul Nizam bin Jamaluddin. So this is our proposed building. Our building was designed based on the functionality of an office building. As we can see on the display, the plan layout and the front view are as follows. Next, we also make a 3D modeling using SketchUp software. The general specifications of the designed building are: the location of the building is subjected at Zone 1 for wind loading with the bearing capacity of 200 kN per meter square. The concrete grade is C35 with yield strength of steel 500 Newton per millimeter square, and the unit weight of concrete is 25 kN per meter square. The height of each level is 4 meter. The GK that we are proposing is 1.35 kN per meter square and QK with 2.5 kN per meter square according to MSEN 1991-1-1 2010 National Annex, with an addition of 1.0 kN per meter square partition. The dimensions as well as bar and link size are as follows.
Hello, Assalamualaikum. My name is Nur Farahin binti Muhammad CF180061. I will explain about slab. This is our plan layout. For panel AB12 case 4 at short span, in medium span, we got 13.5 kN meter. At the support 18.1 kN meter. For the bar at mid span, we were using H12 300. At support, we were using H12 250. At the long span, in mid span, we got 9.8. We were using H12 300. At support, we got 12.93. So we are using H12 300. For panel BC23 case 1, for short span, in middle span 38.1 kN meter, we are using H12 175 bar. At the support 33.2, we are using H12 225, and for the long span at mid span, we got 27.9. we are using H12 250, and at the support 70.7, we are using H12 325. At the panel AB23 case 2, for short span, at the middle span 12.05 kN meter, we will use bar H8 225. At support 16.07, we are using H10 250 bar. At the long span, for middle span, we got 8.04, and we are using H8 300. At the support 10.62, we are using H6 300. For panel CD 4 to 5 case 3, at the short span, in mid span, we got 13.5, and we are using bar H8 200. At the support 18.1, we are using H8 150. At the long span, at mid span 9.8, we were using H8 225, and at the support 12.9, we were using H8 200 bar.
Next, I will present about wind load. We all know that wind force are variable loads which act directly on the internal and external surface of the structures, and wind velocity is dependent on geographical location, the height of the structure, the topography of the area, and the roughness of the terrain. Next, for the calculation of the wind load, our building specification at the flat area and dimension: height 20 meter, width 20 meter, and length 30 meter. For building usage, for the permanent office and our location at the suburban at the zone 1. Next, for the characteristic wind load, we get 3.25 kilonewton meter height, and design wind load WD, that is 3.9 kilonewton meter per height. And this is our point load. We have at the level 1 we get 14.6, and level 2, level 3 and level 4 all we get 15.6, and lastly level 5 we get 11.7. And for the ground floor height we get 3.5 meter, and all each 4 meter. And this is for bending moment due to vertical load 1.2 GK plus 1.2 QK. We get this diagram. And next, for the bending moment due to the wind load 1.2 WK, we get this diagram. And lastly, for the combination of vertical wind load 1.2 GK plus 1.2 QK and 1 plus 1.2 plus WK, we get this diagram. That's all from me. Thank you.
Discuss and recommendation will be presented by me, Nurhida Hamid Ahmad. From the project, we discussed that the bending moment and the shear force diagram as well as values proves to be difference between manual calculation and step pro analysis. The possible reason for these differences are human error, step pro percent of accuracy, the manual calculation is based on ULS, and the lastly is step pro analysis is based on envelope loadings. And then in real life situation, design based on step pro is the recommended way, even though the manual calculation is as important, but not as accurate as step pro. The manual calculation only help us to solve problems on site.
That's all from us. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.